Right, so mathematical induction for this question. This was an exam, obviously. Can't remember which one, 2000 and something. Okay, so have pre-filled a lot of the basic statements. So remember, you must write your Pn. We've proved that P1 is true. Okay, left-hand side equals right-hand side, and you've put in all the little steps in between. And then again, you've got to make sure that you've said, therefore, P1 is true. We've written out assume PK is true, and to prove PK plus 1 is true. So all pretty basic, it's just substituting. Now the maths begins. Okay, so we start with our left-hand side, and we know that all of this up to here, right, that is your PK. So that's this bit here. So we can now say that the left-hand side is K all over 2K plus 1 plus our K plus first term, which we've got here, is 4K plus 1 squared minus 1. And we've got our eyes on the prize, which is this. That's what we want to make this left-hand side equal to. So if we were just sort of going randomly, we would sort of go, oh, let's just get our common denominator. Now, if you look at that, it looks a little bit hideous if I was to multiply these two things together. And again, think about what is it that we want the denominator to be. We want it to be 2k plus 3. So instead of just going straight into timesing the denominators together, I'm going to look at this, and I'm going to see if I can simplify it first, just on a random, right? Just to have a look. So we've got 4k plus 1 squared. Take 1, right? We expand that. We get k squared plus 2k plus 1. Because I'm thinking if I have to multiply these two together and then cross multiply, it's just going to be a little bit messy. And I'm seeing by any chance, right, just hoping that it might be a little bit easier and I might be able to pull out a common factor or something. That's the dream, that's the hope. So I expand the denominator like this, and I'm a little bit disappointed because I don't have a common factor of 4 or anything like that. However, what I was hoping for, one of two things. I was hoping that I might get a common factor of the 2k plus 1, or my answer denominator of 2k plus 3. So I'm going to start with the 2k plus 1, and I just go, could I factorize this? Any chance? Is there the off chance that I could factorize this? So 2k times what will give me the 4k squared, and it has to be 2k, and 1 times what gives me the 3. Oh, look at that. 2k plus 3, right? Now, it would be perfect if it was actually true. Does this equal this if I expand it? 2k times 2k is 4k squared. 2k times 3, 2k times 3 is 6k. And then I've got another 1 times 2k, so that gives me the 8k in the middle there. And 1 times 3 is indeed 3. So, yay! This works really well. Funny about that. All right, that I can now write this as 1 over 2k plus 1 times 2k plus 3. So now that is my common denominator, and I haven't had to do a times the denominator this by this and make it really ugly. Okay, so my common denominator will be 2k plus 1 times 2k plus 3. So what did I have to times? What do I have to times this by? Oh, better that by, to get my denominator here. Obviously, I had to times the denominator by 2k plus 3. So what I do to the bottom, I'm going to have to do to the top. So I'm going to have to times k. Right, so I had to times that by 2k plus 3. And that means I'll have to times the top by 2k plus 3. So now we've got k times 2k plus 3. Right, what did I times this one by to get the denominator? Well, just 1. So we times the top by 1 plus 1. Okay, our game plan, we're always looking once again, right? We're looking at this right-hand side. So what I'm hoping for is that my denominator here of that one, that has to disappear because it's not in my answer on the right-hand side. So hopefully, once I fiddle with the top, there should be a common factor of the 2k plus 1. So we get 2k squared plus 3k plus 1 all over 2k plus 1, 2k plus 3. And by the way, this thing here that we did, right, in your test, you're going to have no calculator available to you. And so the fact some of you were going, oh, I find these ones really hard to factorize. Remember, by looking at your right-hand side and the denominator that you already had, that gave us a clue, okay? This one that we're now trying to factorize isn't as hard as that one if you struggle with these. But remember, we said we want to be able to pull out this common factor of 2k plus 1 so we can cancel it. So again, I'm starting with 2k plus 1. 2k times what gives me 2k squared? Well, it has to be k. And of course, 1. Double check, expand that. Do you get the top? And lo and behold, you do. So denominator 2k plus 3. And yeah, we can cancel. And that leaves me with k plus 1 over 2k plus 3. Let's just go up and have a look. Was that the right-hand side that we wanted? Yes, yes, yes it was. Okay, exploding fireworks celebration. Oops. Okay, so that means that equals the right-hand side. Now we'll go back to our green. Therefore, p k plus 1 is true. And you can write the statement, right? Don't forget to write your statement. Now, that's great. So that's part A done. Let's have a look at part B. Okay, so now we're wanting to do part B. And we've got this hence. So you must use the thing that we've just proved. Hence, find in simplest rational form the value of this. And we go, what's going on there? Well, look at your original statement and see if you can get any similarities. So if I was to actually work out, all right, this bit here, I've got 1 over 4 times 1 squared is 4. Take 1 plus 1 over 2 squared is 4. 4 fours are 16. Take 1. My next term would be 4 times, so I'll just pop that there. The next one would be 4 times 3 squared. Take 1. Okay, that makes 3 squared is 9. 9 fours 36. Hopefully you can see where this is going. All right, so this now becomes 1/3. This is 1/15. This is 1/35. So you can see that this is now looking like this. What is your n value going to be, right, for this one? Because when we were doing this, this is when n equals 1, this is when n equals 2, and this is when n equals 3. So what would n have to be to get 399? You can play around, but hopefully you can see that it has to be 10. Right, so that would be 1 over 10 squared is 100. 100 times 4, we get 400. Take 1, and lo and behold, we've got 1,399. So if I was to add up all of this, and we're going up to n equals 10, right, that's going to equal my right-hand side here. That's going to be 10 over 2 times 10 is 20 plus 1, so that's going to equal 10 over 21. However, the question isn't asking me for all of this, is it? It's only asking me for this. Okay, which means, therefore, if I'm looking at 1/15th plus 1/35th, all the way up to 1 over 399, well, that's going to be your 10 over 21, but I'm going to have to subtract the 1/3. Okay, let's do that. Again, I'm just playing around. Look, in an exam, you're going to have your calculator. Boom, you do that really swiftly. But imagine if this is a test question, you don't have your calculator. So we're doing simple fraction work, which should not slow us down really. Okay, 10 take 7 is 3 over 21, and that can cancel even further because 3 goes into 21 7 times. Huzzah! Okay, so with your Part B questions, always go back and think about how you can use the thing that you have just proved, and it's because of this hence.